Saturn, the crown jewel of our solar system. The iconic rings, the pale gold glow, breathtaking, isn't it? But beneath this beauty lies the most terrifying trap. The prettier it looks from far away, the more dangerous it becomes when you try to go there for real. And when I say go there, I don't mean sending a probe that doesn't have to eat, breathe, sleep, or survive mistakes. I mean a Saturn mission with humans. A mission where people are actually inside the spacecraft, planning to take a trip and come back in one piece. But that's not how it will happen. Because that return part is where the entire idea starts collapsing. Not because Saturn is haunted, or because it's impossible to reach. We've reached it. We've flown past it. We've orbited it. We've studied it up close. The real problem is this. Saturn is the kind of place where the journey is so expensive and so fragile that the moment anything goes even slightly wrong, coming back stops being a plan and turns into a hope. And hope is not a flight system. Today, we're breaking down exactly why a trip to the ringed planet is a one-way ticket to oblivion. From the soul-crushing pressure to the fact that the ground literally doesn't exist, here's why anyone who goes to Saturn is never, ever coming back. Let's begin. Let's start with the most obvious problem. Saturn is a gas giant. That sounds pretty light, doesn't it? Like a cloud? But you're so wrong. If you jumped out of your spaceship expecting to land on a dusty, cratered surface like the Moon or Mars, you're in for a terrifying surprise. You would just keep falling. Because there is no ground, no surface like Mars, no rocky crust like Earth. You can approach the top layers. Sure, you can enter the clouds too, but as you go deeper, it doesn't turn into land, just intense pressure, more density, intense heat, and more violence. Because it's mostly hydrogen and helium. So as you descend, the air around you just gets thicker and hotter. It's almost like being dropped into the middle of the ocean, except this ocean is 45,000 miles deep and made of liquid metal at the bottom. So if someone says, "What if an astronaut steps onto Saturn?" The honest answer is, they can't. They just can't. There's nowhere to stand. The best you can do is hover, float, or descend. And every second you descend, the planet becomes a stronger and stronger machine, designed to crush things. The atmosphere gets thicker. The pressure climbs. The temperature rises. Materials that work near Earth stop working. Electronics struggle, structures bend, and you don't get a dramatic moment where you hit the ground. You just get a slow, terrifying loss of options. And this matters for one big reason. If you can't land, you can't build a base on Saturn. You can't refuel on Saturn. You can't repair on Saturn. You can't do the normal human mission where you arrive somewhere, stabilize, and then launch again later. A Saturn mission, if it's human, is almost forced to be orbital or focused on a moon like Titan or Enceladus. But even then, you're still inside Saturn's system, and Saturn's system has rules that do not care about your exploration. Now, let's talk about the part most people underestimate, fuel math. Space travel is not about speed. It's about changing speed at the right times by the right amount. That change is called delta velocity, and delta velocity is basically the currency of space missions. You spend it to leave Earth, to adjust your path, to slow down, to enter orbit, to transfer between orbits, and to escape again later. Here's the brutal part. It's not just that Saturn is far. It's because Saturn is massive, and a massive planet creates a deep gravity well. That means you don't just arrive and park your car. If you come in too fast, you fly right past. So you need a huge braking plan. But braking in space isn't brakes. It's fuel, it's engine burns, timing, and precision. And the same is true for leaving. In a Saturn mission, getting there is already expensive. But leaving Saturn's region, escaping its gravity influence, and setting a clean path back home is where the math gets mean. Every kilogram of extra fuel you want for the return trip makes your ship heavier, which demands more fuel to move that extra fuel. This is why engineers fear the rocket equation. It's not a slogan. It's a trap. The more you try to make the mission safer by carrying more, the more the mission becomes heavier, slower, costlier, and harder to launch in the first place. Let's talk about pressure. On Earth, we have about 1 bar of pressure at sea level. We're built for it. It feels like nothing. But as you sink into Saturn's atmosphere, the weight of all that gas above you starts to stack up fast. Within minutes of your landing, the pressure becomes equivalent to being miles underwater on Earth. Your spaceship, the one you spent billions of dollars on, would start to groan. The hull would buckle. Eventually, the pressure gets so high that it does something weird to chemistry. It turns hydrogen into a liquid metallic state. Imagine a sea of liquid metal that conducts electricity. By the time you reach this layer, you wouldn't be an astronaut anymore. You'd be a crushed metallic pancake. If the pressure doesn't get you, the weather will. We think a Category 5 hurricane on Earth is scary? That's like a gentle breeze compared to Saturn. Winds at Saturn's equator can reach speeds of over 1,100 miles per hour. That is faster than the speed of sound. If you were caught in these winds, you wouldn't just be blown away, you'd be shredded. And then there's the hexagon. At Saturn's North Pole, there's a literal 6-sided storm that's wider than 2 Earths put together. We don't fully understand why it's a hexagon, but we do know it's been raging for decades, maybe centuries. It's a permanent, geometric nightmare that would swallow any rescue mission whole. Now let's talk about radiation, because this is where a lot of people get confused. Space radiation is already a major issue near Earth. But when you go deep into the solar system, you're exposed for longer, and Saturn has a magnetosphere that traps charged particles in complex ways. Different regions in Saturn's environment can have different radiation conditions, and the mission has to navigate those conditions without cooking the crew over time. Shielding helps, but shielding adds mass. Mass increases fuel needs. Fuel increases mass. And suddenly, you're back in the rocket equation trap. Everything is connected. That's why Saturn is so hard. It's not one danger. It's the way every solution makes another problem worse. So when people say never come back, the realistic meaning is this. The return trip is the first thing to die when anything goes wrong. If your propulsion system gets damaged, the return is gone. If your power system fails, the return is gone. If your life support starts degrading faster than expected, the return is gone. If your mission timing slips and you miss an optimal path home, the return becomes harder, longer, and riskier. The mission might still be alive, the crew might still be alive, but the plan to return can quietly evaporate while everything still looks fine on paper. And this is the part most people don't want to hear. Then comes the danger people love to romanticize: Saturn's rings. In photos, they look like a smooth, thin disc, like a delicate halo, but the rings are made of countless particles. Some are tiny dust, some are chunks of ice, some are larger pieces, and the key detail is speed. Everything in orbit is moving fast, very fast. So even a small piece can become dangerous if you meet it wrong. A spacecraft near the rings has to navigate with serious precision. You don't want to be in a region where debris density is high. You don't want random collisions, and you don't want to rely on luck. Because in a human Saturn mission, a puncture isn't a dramatic movie moment, it's a countdown. And if something compromises the ship's structure, the return trip becomes irrelevant. You don't return from a failure that happens too far away. But even if you avoid the rings, Saturn has another monster: weather. On Earth, weather is a layer. On Saturn, the weather is the planet. The atmosphere is active, deep, and powerful. Winds can be extreme, storm systems can be huge. And the deeper you go, the less your vehicle controls the situation and the more the atmosphere controls you. If a probe descends and gets swallowed by storms, that's still a data win. For humans, that's a nightmare, because you can't rely on a rescue craft. There is no rescue craft. You are the rescue craft. A Saturn mission has to be designed under the assumption that the crew solves problems alone, with what they brought, with what still works, and with whatever time they have left before the problem becomes irreversible. So, why will no one ever come back from Saturn? Because Saturn isn't a destination. It's a gravitational giant that consumes everything it touches. It has no floor to stand on, no air to breathe, and weather that makes our worst disasters look like a sunny day at the park. We can send probes, take beautiful photos from the safety of orbit. But as for humans, we're better off staying on the blue dot, admiring the rings from a distance, because once Saturn pulls you in, it never, ever lets go. If you enjoyed this deep dive into the horrors of the gas giants, hit that subscribe button and let me know in the comments which planet should I visit next. Just maybe one with actual ground this time. Thanks for watching.